Maths department from Tirthangal Nadar College. So today we are going to see some portions on integral calculus. In that we are going to see reduction formula. So the content of the video is we are going to see Bernoulli's integration and reduction formula for all the trigonometric ratios. So what is reduction formula? Reduction formula is the one we will be having the power n which will be reduced. So for that sake only it is named as reduction formula. So the first one is we are going to see Bernoulli's formula. What is the Bernoulli's formula? Integral u dv is equal to uv minus u dash v1 plus u double dash v2 minus u triple dash v3 plus u fourth dash v4 and so on, where u dash and u double dash, u triple dash are successive differentiation and v1, v2, v3, v4 up to vn are successive integration. We are going to see the problems based on Bernoulli's integration. The first problem is integral x cube e power x, integral x cube e power x dx. So as of Eilert concept, what is Eilert concept? While choosing u, we want to give the preference for Eilert. I denotes the inverse trigonometric function, and L denotes logarithmic function, and A denotes algebraic function, T denotes trigonometric function, and E denotes exponential function. Here we are having two functions, x cube and e power x. So x cube is algebraic function and e power x is trigonometric functions. Okay. So we are choosing a algebraic function x cube as u. So when we differentiate x cube, it is 3x square. So we are using the formula differentiation of x power n. Differentiation of x power n is nx to the power of n minus 1. So when x cube is differentiated, it is 3x square. It is again differentiated, it is 6x. It is again differentiated, it is 6. So when we differentiate again, the constant term is 0. So we are stopping with this. Since we are having u triple dash, we want to find up to v3. So what is integration of e power x? When we integrate e power x, it is e power ax by a. Here we are having 1, so no need to put 1. So when we integrate v, it is e power x, again it is e power x, e power x, e power x. So when we are substituting in the formula, when we are substituting in the formula, integral u dv is equal to uv minus u dash v1 plus u double dash v2 minus u triple dash v3. We are getting it. When we substitute in the formula, we are getting the answer. One more problem, it is x square e power minus 3x. So what we want to choose as u, again we are having two functions, algebraic function and exponential function. So the preference will goes to algebraic function. So we are choosing u as x square. So when we differentiate once, it is 2x, again we are differentiating it as 2. So we are integrating this again using the same formula. Integration of e power ax is e power ax by a. So it is e power minus 3x by minus 3. So there is no need to keep the negative sign in the denominator, so we are taking it off. So it is minus e power minus 3x by plus 3. So again we are integrating it using the same formula. It is e power minus 3x by minus 3 into minus 3. It becomes 9 and v2, and we are substituting in the formula Bernoulli's integration. And this problem you can try it as homework. Okay. And the next one. Now we are going to see the reduction formula for all the 6 trigonometric ratios. The first one is integral 0 to pi by 2 sine power nx dx. So however we want to differentiate this, integrate this. So for that sake we are reducing the power as n minus 1 into sine x. Okay. So this sine power, we want to take this nth power as in. Since it is integration, we are taking it as in. So sine power n is reduced as n minus 1 into sine x. Again we are going to use integration with parts. The formula for integration by parts is integral u dv is equal to uv minus integral v du. Here we are treating this, we are having two functions, sine power n minus 1 and sine x. So we are taking algebra, so as sine power n minus 1, so it is u, we are taking as sine power n minus 1 and the remaining terms as dv. So what is differentiation of sine power n minus 1 x dx? So differentiation of x power n is nx to the power of n minus 1. Using the concept, we are having n minus 1 into sine power n minus 2x into cos x. So the remaining term is dv. So dv is sin x. When we integrate sin x, it is minus cos x. So it is minus cos x. Here first we want to differentiate using the algebraic concept x power n. Differentiation of x power n is nx to the power of n minus 1. Nx to the power of n minus 1. Again we want to differentiate this sin x. So differentiation of sin x is cos x. So for that reason only we are having cos x here. Okay. the next one is, okay, now we are substituting in the formula integral uv minus integral v du. So when we substitute in the formula, we are getting this. After substituting in the formula, we want to substitute the limit. This term will be vanished as we are substituting the limit. When we substitute the value of pi by 2 and 0 to x, sin 90 it is 0, so 0 into anything is 0. Again sin 0 is 0, 0 into anything is 0, so this term will be vanished out. So it will be having only that. So here this negative and negative becomes positive, and n minus 1 we can take it outside. So we are having this. Now using the basic trigonometric formula, sin square x plus cos square x is equal to 1. For cos square x we can substitute 1 minus sin square x. So we are substituting 1 minus sin square x, and we are taking this sin power n minus 2 inside the bracket. So we will be having this. So here sin power n minus 2x dx minus sin power n minus 2 into sin square x. If the base is same, we can add the powers. So that only we are going to do on the next. Yes. The next one, we are taking that inside. So we are having this, and again we are taking this n minus 1 inside. So this is the question which we are having, in. In is sin power n. Here we are having sin power n minus 2. So it is in minus 2 and in. So this side also we are having in, and this side also we are having in. When we take this in to this side, it comes as positive n minus 1 into in. So taking out in common and cancelling out the terms, we will be having in is equal to n minus 1 by n into in minus 2. Put n is equal to, see now the power is reduced in sin, in is reduced to in minus 2. Keep on further reduction, put n is equal to n minus 2 in equation 1. Here we are needing n minus 2, we need n minus 2, so put n is equal to n minus 2 in equation 1. When we substitute n minus 2 here, it becomes n minus 3 and n minus 2 by n minus 4. And put, there we are having in minus 4, we put n is equal to n minus 4 in equation 1, we are getting this step and so on. So substituting 2 and 3 in equation 1, we will be getting the formula like this, n minus 1 by n minus 3 by n minus 2, n minus 5 by n minus 4, and it's keep on reduced, and the last term will be I0 if n is even, and the last term will be I1 if n is odd. In particular, we are searching for I0. So I0 is sin power 0x dx. Anything to the power 0 is 1, so it is dx. When we integrate dx, it is pi by 2. And similarly, I1, integration of sin x is minus cos x. So when we substitute the limits, we will be getting this. So the formula will be in is equal to sin power n. So this is the formula, n minus 1 by n minus 3 by n minus 2, n minus 5 by n minus 4, and so on, 1 by 2 into pi by 2 if n is even, n minus 1 by n minus 3 by n minus 2, n minus 5 by n minus 4 into 2 by 3 if n is odd. We'll see some problems based on this. Evaluate sin power 5x and sin power 6x dx. So we have wrote the formula which I have seen earlier. This is the formula for sin power nx dx. Here n is equal to 5. Here n is equal to 5. So when we substitute in the formula, 5 minus 1 by 5, 5 minus 3 by 2. 5 minus 5 is 0, so we are not supposed to put that. We want to stop the problem once 1 by 2 comes. See here, 1 by 2 or 2 by 3 comes. So here it is 2 by 3 odd, so we will wind up with 1. When we settling this, we are getting 8 by 15. And similarly, I6, same substituting in the formula, we are not supposed to put 0. So 6 minus 1 by 6, 6 minus 3 by 2. Substituting, at last when we are getting 1 by 2, we want to put pi by 2. That is the value of I0. So when we are cancelling and settle it, the answer is 5 pi by 32. The next one, similarly cos power nx dx, same as we did in the earlier problem. We are splitting the powers into n minus 1 into 1. Same integration by parts, we are taking cos power n minus 1 as u. So when we differentiate this, x power n, treating this as algebraic function, differentiation of x power n is nx to the power of n minus 1, and differentiation of cos x is minus sin x. So this is the answer for du, and when we integrate dv cos x, it is sin x, and we are substituting in the formula, again integration by parts, uv minus integral v du. Again this term vanishes as we substitute both the limits. So cos 90 is 0 and sin 0 is 0. So we will be left up with this term. Here we are having one negative sign, here we are having one negative sign. So that becomes positive, and we are taking n minus 1 as common. So we will be left up with this. So this sin square and sin square this becomes that sine and sine becomes sine square. So basic trigonometric formula sine square x we can use 1 minus cos square x, and we are taking the cos power n minus 2 inside the function. So we'll be having this. Yes, we are substituting the formula, substituting the one in and taking in to this side. So this is the formula as sine power n. This is also done for cos power n. So here we are having n and here it is n minus 2. It is reduced. N is reduced to n minus 2. We want to find n is equal to n minus 2. So put n is equal to n minus 2 in equation 1. We will be having this n minus 3 by n minus 2. Further we are having n minus 4 here. So we want to put n is equal to n minus 4. So putting n is equal to n minus 4 in equation 1, we are having this. It keeps on reduced till I0 and I1. So and so on. Substituting 2 and 3 in equation 1, we are getting this n minus 1 by n minus 3 by 2, n minus 5 by n minus 4, and so on. I0 if n is even, I1 if n is odd. So in particular we want to find I0 and I1. So I0, anything to the power 0 is 1, it is 1 dx. When we integrate it is x. Substituting the limit, it is pi by 2. So similarly, I1 is cos x. If cos x is integrated, it is sin x. So we are substituting the limit and finding it as 1. So the formula for cos power n x dx is n minus 1 by n minus 3 by n minus 2, and so on. 1 by 2 into pi by 2. Similarly for odd. So we have worked out two problems here, same as sine. So if it is 5 here, so when we are substituting in the formula 5 minus 1 by n, it is 4 by 5, 2 by 3, it is 8 by 15. Similarly, cos power 6 is I6. So 6 minus 1 is 5 by 6, 3 by 4, 1 by 2, pi by 2. So the final answer is 5 pi by 32. The next one is the reduction formula for sine power mx and cos power mx dx. Now we are going to see both. In the last one we have seen sine power n and cos power n. Now we are combining both the functions sine power m and cos power nx dx. So since we are having two powers, we are taking this as I power im. Okay. Since we want to do something, so I am reducing the power, splitting the powers of cos power n. So it is cos power n minus 1x into cos x dx. So again, treating the algebraic function, I am taking this term as u. So cos power n minus 1x dx. So what is differentiation of x power n? It is nx to the power of n minus 1, and differentiation of cos x is minus sin x. All the remaining terms will be taken out as dv. So it will be having sin power mx cos x. So this differentiation of cos x, this cos x can be written as differentiation of sin x. Differentiation of sin x is nothing but cos x. So we are rewriting this. So what is the formula for integration x power n dx? It is x power n plus 1 by n plus 1. So the formula, using the formula, here also sin, here also sin. So we can use that formula. So sin power n plus 1 by n plus 1. Okay. Now using the same formula, again using integration by parts, integral u dv is equal to uv minus integral v du. We are substituting in the formula. Again this term vanishes because of cos pi by 2 and sin 0. So it will be left up with these terms. In numerator we are having n minus 1 here and n plus 1 here. So one more step we are doing here. So here we are having sin power m plus 1. Here we are having 1 sin. So this and this becomes sin square x, right? After that we will be substituting. After that we will be substituting sin square x using basic trigonometric formula. We are substituting 1 minus cos square x, and we are taking the cos power n minus 2 inside the bracket. So we will be having this. Again we are taking this n minus 1 also inside. So using reduction concept, m will be the same. Now n is reduced to n minus 2. Here we are having I power imn, and this side also we are having imn. So we are taking this negative term to this side. This comes as positive. Since imn is common, we are taking imn outside and taking LCM. Settling out, we will be having m plus n by m plus 1. When this comes to this side, becomes m plus 1 by m plus n. Both m plus n will be cancelled. So this is the formula for imn. Okay. Now we will be having cases. Since n is equal to n minus 2, it keeps on reduced till I0 and I1. So we will see in the next slide. Here m is equal to n and n is equal to n minus 2. The same manner we are substituting in equation 1. So substituting, it becomes n minus 3 by n plus n minus 2 I m comma n minus 4. again we need n minus 4. So we need to put m is equal to m and n is equal to n minus 4 in equation 1. So I m comma n minus 4 is equal to I m comma n minus 6. So it keeps on reduces and so on. So substituting in the equation, we'll be having I m n is equal to n minus 1 by m plus n minus 3 by m plus n minus 2 and so on. If n is even, it will be end up with I m comma 0. If n is odd, it will be end up with I m comma 1. So in particular case, we want to find I m comma 0 and I m comma 1. Right? So case 1, if n is even. If n is even, we'll be having this cos power 0x dx. In the first problem, we have discussed sin power n. So this case will come here. This is the formula which I have discussed in the first problem. If n is odd, we'll be having like this, like case n is equal to 1 cos x. So this differentiation of cos x can be written as, this cos x can be written as differentiation of sin x. So when we integrate this, so it is sin power mx sin x. Again using the integration formula x power n dx. What is x power n dx? X power n plus 1 by n plus 1. Using the concept, and again we are substituting the limit. Sin 90 is 1 and sin 0 is 0. So we'll be having 1 by m plus 1. So the formula for if n is odd, m may be odd or even. This is the formula. So I have given all the formulas in a separate slide. So Imn is equal to, based on n is even, we are having two formula. If n is even, m is even, we have a separate formula. N is even, m is odd, we have a separate formula. If n is odd, we are having a single formula. This is a consolidated formula of all the above discussions. Now see the problems based on that. So here we are seeing the formula problem sin power 6 and cos power 4x dx. Here m is 6, n is equal to 4. If n is even, we are having two formula. If n is even, we are having two formula based on m. If m is even, we are having the above formula. If m is odd, we are having the above formula. Using the formula, we will be substituting, we will be getting this. Here m is equal to 6 and n is equal to 4. So when we substituted in the formula, m by m minus 1, m minus 1 by m, so 5 by 6, 3 by 4, 1 by 2. Once 1 by 2 comes, we will be substituting 5 by 2. For n, it is n by m plus n. So n minus 1 by m plus n. So 3 by m plus n is 10. Again n minus 3 by m plus n minus 2, it is 10 by 8. So when we are settling it, we will be getting this. Same problem. If n is odd, we will be having only one formula. This is the formula. In this formula, we have just substituted, we will be getting the answer. And we are moving to the next one. So far we have seen sin power n, cos power n, and both sin power m and cos power n. Now we will see other reduction formulas. So this is the formula for tan power n. So again tan power n, this tan power n can be splitted as tan power n minus 2x into tan square x. Why it is splitted as tan square x? Because we are having the basic trigonometric formulas. Secant square x minus tan square x is equal to 1. In case 2, you apply that formula, I am splitting in powers of 2. Right? So here this tan square x can be written as secant square x minus 1. I am taking this inside. So taking this inside, you will be having this 1. Now this secant square is nothing but differentiation of tan x. Differentiation of tan x is secant square x. So in case 2, write it as x power n dx. So if it is x power n, it should be, if it is tan, this should be tan. So I am writing this secant square as differentiation of tan x. Using the basic integration formula x power n dx, it is x power n plus 1 by n plus 1, and this is reduced to in minus 2. So this is the formula for tan power nx dx. Now, so it is the formula for in tan power n minus 1x, in minus 1. If n is even, it will be ended with I naught. So it is x. If n is odd, it will be ended with tan x. Different integration of tan x is log secant x. Okay. So we'll see some problems, few problems based on this. Integrate tan power 4x dx. So we can use the formula also. So this is the formula which have derived earlier. So integral tan power nx dx is tan power n minus 1x by tan n minus 1 minus in minus 2. Here n is equal to 4. So when I am substituting here, I will be having this. Again I will be having I2. So tan square can be written as secant square minus 1. So integration of secant square x is tan x and integration of dx is x. and taking the negative sign inside. This is the one way of doing. We are seeing a later also. So this is tan power 4x dx. The editor of the problem doesn't need to apply the formula. We can do like this also. Tan power 4x is split into tan square. So tan square is nothing but secant square x minus 1. I am taking this tan square inside it. So we will be having this. Again this secant square is written as differentiation of tan x. So this tan square x is secant square x minus 1. When we apply the formula, it is x power n dx. X power n plus 1 by n plus 1. Integration of secant square x is tan x. This minus and minus at last becomes plus. Integration of dx is x. So this is the other way of doing. Either you can use the formula or you can do like this. Okay. Now we are going to see the other. Yes. Now we are going to see the cot power n. So cot power n, same way, basic trigonometric formula. Cosecant square x minus cot square is 1. So in case to apply this, I am splitting the powers as cot power n minus 2x and cot square x. So in the place of cot square x, I can write it as cosecant square x minus 1. I am taking this cot power n minus 2 inside the bracket. So it will be having this. So before applying differentiation of cot x, differentiation of cot x is minus cosecant square x. So I am multiplying minus 1 and minus 1. Minus 1 and minus 1 is nothing but plus 1. So treating here we are having plus. So I am just multiplying negative side inside and inside the minus cosecant square x. This side simply it will be reduced. Okay. So differentiation of cot x is minus cosecant square x. Again we can use the formula. What is the formula? Integration of x power n dx is x power n plus 1 by n plus 1 and in minus 2. So we will be having this. So this is the formula, and again this n will be keep on reduced to I0 and I1. I0 it will be x if n is even. I1 it is log sin x. So this is the formula for cot power nx dx. Next it is secant power n x dx. In all the other trigonometric ratios we will be splitting the powers in terms of 2. Okay. So it is secant power nx, we will be splitting the powers as secant power n minus 2x into secant square x. Secant square x is differentiation of tan x. Okay. So differentiation of tan x. So here we want to apply integration by parts. Integration by parts formula is integral u dv is equal to uv minus integral v du. When we substitute in the formula, taking this as algebraic function as u. So what is differentiation of x power n? Nx to the power of n minus 1. So n minus 2 secant power n minus 3x and secant x. Differentiation of secant x is secant x tan x. So we are taking the remaining term as dv. What is differentiation of integration of dv? It is v. So when we differentiate tan x, when we integrate d tan x, it is tan x, and we are substituting in the formula integral uv minus integral v du. So u it is secant power n minus 2 and tan x minus integral v du. I have just substituted in the formula. Integral u dv is equal to uv minus integral v du. So next slide. So we are having, see in this slide, here we are having a negative sign, and we can take this n minus 2 as common since it is a constant term. So I am taking n minus 2 outside. So we are having tan square, here we are having tan x, and here secant x tan x. We are having one tan. So tan x into tan x becomes tan square x. Here we are having n minus 3 and 1 secant x. So if the base is same, we can add the powers. So n minus 3 plus 1, it becomes n minus 2. So we are having secant power n minus 2x and tan square x, right? So this tan square x can be again written as secant square x minus 1. So it becomes secant square x minus 1. I am again taking this secant power n minus 2 inside the bracket as also this n minus 2 to both the terms. Okay. So if it becomes get inside, so it is n minus 2 plus 2. It becomes secant power n and secant power n minus 2. Here we are having a negative sign and here we are having a negative sign. So that becomes positive. So it will be having this. Now we can apply the formula, apply the one which we have reduced. So in is equal to, this term will be the same, minus n minus 2. This is secant power n is in, n minus 2 into in minus 2. Right? Now here we are having in and here we are having in. We are taking this to this side, taking out in common. We are splitting up, settling it, will be getting n minus 1. When this n minus 1 comes this side, it becomes secant power n minus 2x tan x by n minus 1 plus n minus 2 by n minus 1 into in minus 2. Now in is reduced to in minus 2. It keeps on reduces till I0 and I1. If n is even, it will be reduced to I0. If n is odd, it will be reduced to I1. So if n is even, it will be reduced to I0. So integration of dx is x. So if n is odd, it will be reduced to I1. So integration of secant x is log tan x plus secant x. Right? So we'll see few problems based on secant power nx dx. So here we are having secant cube x. Secant cube x can be splitted as secant x into secant square x. This secant square x can be written as differentiation of tan x by using integration by parts. So again we are using integration by parts. Integral u dv is equal to uv minus integral v du. So u we are taking as secant x and the remaining part as dv, right? So differentiation of secant x is secant x tan x. When we integrate this, v is equal to tan x. Substituting in the formula uv minus integral v du, will be having this. This tan and tan becomes tan square secant x. So basic trigonometric formula, tan square x can be written as secant square x minus 1. So I am taking this secant x inside. Yes, I am taking this secant x inside. So this becomes secant cube x dx minus secant x. So what is secant cube x dx? Again we are getting the same which is in the question. It is I3, right? Yes, it is I3 and integration of secant x is log secant x plus tan x. So when we substitute here, so when this I3, when it comes this side, it becomes I3, minus I3 becomes plus I3. So we will be having all these terms. I3 plus I3 is 2I3, so that 2 comes this side. So this is the form, this is the one which we have written as we know. So we can use the formula also. Just we have derived it. In is equal to earlier. This is the other method which we are using the formula. So in is equal to secant power nx dx. This is the formula which we have derived. Here n is equal to 3. N is equal to 3. So 3 minus 2 is secant x tan x by 3. 1 by 2 I1. So what is I1? Integration of log secant x is log secant x plus tan x. This is also the way we can go. If it is hard for us to memorize the formula, we can go with the above method. Okay. So I have did one more problem based on secant. It is secant power 6x dx. So secant power 6x dx can be splitted as secant power. All the trigonometric ratios other than sine and cos will be splitting in the powers of 2. Right? So secant power 4x can be splitted as secant power 6x can be splitted as secant power 4x secant square x. So again secant square x can be written as differentiation of tan x. So this secant square x can be written as secant square x the whole square, secant square x the whole square. So what is secant square x? 1 plus tan square x. So using substitution method, I can take tan x as t. See, here we are not going with integration with parts because here also we are having tan. So in terms if we have tan here, I can use the formula integration of x power n. Integration of x power n is x power n plus 1 by n plus 1. Using that concept, I am taking t as tan x as t. So it is 1 plus t square the whole square dt. So what is a plus b the whole square? A square plus 2ab plus b square dt. So I am integrating this. Integration of dt is t. Integration of 2t square is 2 is constant. T square is t cube by 3. X power n plus 1 by n plus 1. Same x power n plus 1 by n plus 1. At last I am replacing t by tan x. So this is the answer. Right. So far we have seen tan power n and secant power n. We will see cosecant power n and cot power n. So obtain the reduction formula for cosecant power n. So as I said, the powers is splitted in the powers of even numbers, n minus 2 and cosecant square. And again I am doing one more step here. Since differentiation of cot x is minus cosecant square x, I am multiplying with the negative sign. I am multiplying one negative sign here and one negative sign here. Minus into minus becomes positive. It doesn't affect the above one. So this cosecant square x can be written as differentiation of cot x using integration by parts. Integration by parts, integral u dv is equal to uv minus integral v du. So u is equal to cosecant power n minus 2x dx. So when we differentiate this x power n, nx to the power of n minus 1, differentiation of cosecant square x is minus cosecant x cot x. Here dv, when we integrate, will be cot x, and substituting in the formula integration by parts. Integration by parts, integral u dv is equal to uv minus integral v du. So uv, u and v minus integral v du. Here we want to little careful because we are having a negative sign here, and this negative sign is common for all the terms which is inside. So I am using a clever bracket here. So minus clever bracket, square bracket for uv minus integral v du. You just substitute carefully here so that you will be having these terms. Now I am taking the negative sign inside. So negative sign inside, this becomes negative. See, here we are having one negative sign. Here we are having one negative sign, and here we are having one negative sign. So totally 3 negative signs together becomes negative. So in the second term it will be a negative away, and I have removed the brackets. And here also we are having cot x and cot x, so that becomes cot square x. So cot square x, simultaneously I am substituting here cot square x is equal to cosecant square x minus 1. So I am taking this, splitting the bracket. So I am taking cosecant power n minus 2x. Inside the bracket you will be having this. Again I am taking this n minus 2 inside it. So I will be having it. So it is in. Now it will be reduced to the powers. Again this is cosecant power nx is in, and this is in minus 2. So this is in, and this side also we are having in. So I am taking all to one side. So in plus in. So I am taking in common. If I am taking in common, becomes 1 plus n minus 2. Then we are settling it n minus 1. So this n minus 1 comes to this side. So if n is even, will be end up with I0. So what is I0? I0 is nothing but cosecant power 0x dx. Anything to the power 0 is 1. So it will be left up with dx. Integration of dx is x. So if it is I1 cosecant x, integration of cosecant x is minus log cosecant x plus cot x, right? So we'll see few problems based on this. So cosecant power 4x dx. So as I said, if it is cosecant, we want to multiply with both two negative signs. So it is minus cosecant square x into cosecant square x. This minus cosecant square x can be written as differentiation of cot x, and this cosecant square x using the basic trigonometric formula 1 plus cot square x. Here also cot, here also cot. So we can use the basic trigonometric formula. It is x power n dx. Integration of x power n dx is x power n plus 1 by n plus 1. So I am just substituting cot x is equal to 1. This becomes 1 plus y square into dy. So when we integrate this, what is integration of dy? It is y. Integration of y square dy is y cube by 3. And again I am replacing y by cot x. So one more problem based on cosecant power 5x dx. From the formula, either we can use the formula or we can go with the Alitar method, but now I am using the formula. This is the formula which we have derived above. So here n is equal to 5, I am substituting n is equal to 5 here. So it becomes cosecant cube x cot x by 4, and 3 by 4 into cosecant 3x. Again this becomes I3. Again we want to use the same formula. So when we substitute in the same formula, minus cosecant 3 minus 2 is 1, cot x by 2 plus 1 by 2 I1. So I am taking this 3 plus 4 inside. So this becomes minus 3 by 8, this one, and I1. What is I1? I1 is cosecant x. Cosecant x is minus log cosecant x cot x. When we substitute in the formula, and I am taking that 2 there, so we will be having this. So we have seen all the formula for all the trigonometric ratios. All the trigonometric ratios we have seen: sin power n, cos power n, tan power n, cot power n, and cosecant power n, secant power n. With this, I am winding the video. Thanks for watching.